So now adding one more thing into the mix, we looked at in the last Try It exercise, simplifying radicals that had both numbers and a variable under the radical. Now we're dealing with multiple variables, but the process again is still the same, looking for perfect squares with square roots, looking for perfect cubes with cube roots, so on and so forth. We just have more factors to look at now. So I like to separate it into, because we know we're going to be breaking it up into factors, let's go ahead and break it up into parentheses that we know will hold our 3 factors for each one. So with our first problem, we're given the square root of 98a to the 7th b to the 5th. We want to look at what perfect squares are factors of 98. It's even. If we divide by 2, 98 divided by 2 is 49, which is a perfect square. Square root of 49 is 7. So this is 49 times 2. A to the 7th. With square roots, we just want the largest even factor, even exponent factor. So 1 less than 7 is 6. We're still left with a. A to the 6th times a is our original a to the 7th. And last but not least, we're given b to the 5th underneath here. 1 less than b to the 5th is b to the 4th. And that leaves us with b. b to the 4th times b is our original b to the 5th. Then we separate that into the square root of 49 a to the 6th b to the 4th times the square root of 2ab. Now we could separate this further. We could go ahead and, instead of having just the square root of 49a to the 6b to the 4th, we could take the square root of each one and then square it. This isn't really a necessary step, but to see what we're doing and to make sure we're crossing our T's and dotting our I's, if you're not fully comfortable with the process, I would suggest going ahead and writing this step. So the square root of 49 is 7, the square root of a to the 6th is a cubed, square root of b to the 4th is b squared. That's all being squared. And again, we still have the square root of 2ab. Now when we take the square root of this, we will get the values that are inside the parentheses, but at the same time, we have to remember our absolute value rules. So with 7, that's just a number. The square root of 7 squared is just 7. Now the square root of a cubed squared, cubed is an odd exponent, so we would need to take the absolute value of a cubed. And the square root of b squared is just b squared, and that's because we know that that is positive. And again, that's still times the square root of 2ab. And technically, you could say that it's just as correct to write 7a squared times the absolute value of a times b squared times the square root of 2ab. The reason for that is because we know a squared is positive and it's a factor of a cubed. But either one of these would be sufficient as far as the solution is concerned for the simplification. Now with the cube root, with part B, we're looking at cube root. The cube root of 56x to the 5th y to the 4th, we're looking for perfect cubes. So what are the factors of 56, and are any of them perfect cubes? 56 we know is divisible by 8, which is a perfect cube, and it leaves us with 7, which we really can't do anything as far as that is concerned, as far as cubes are concerned. So let's break this up into 8 times 7. 8 times 7 is our original 56. Factors of 5, x to the 5th, numbers that are less than that are multiples of 3, that would simply just be cubed. So we'll have x cubed times x squared. And again, that's because x cubed is a perfect cube, and x cubed times x squared is our original x to the 5th. And then y to the 4th, again, we'd be looking at y cubed, and that leaves us with y. And again, that's because y cubed times y is our original y to the 4th. Again, we break that up into separate radicals. We can go ahead and say that this is 2xy, and that's being cubed. Because 2 cubed is 8, x cubed is cubed, y cubed, or x cubed is x cubed, and y cubed is y cubed. And again, that leaves us with the other part of the product, the cube root of 7x squared y. No absolute values needed because we're dealing with a cube root, 2xy cubed. The cube root of that is simply 2xy. And we're left with the cube root of 7x squared y. Part C, we're looking at a fourth root. So again, we want perfect quads. The fourth root of, well, 32 divided by 2 is 16, which we know is a perfect quad. 2 to the 4th is 16, so 16 times 2 gives us our original 32. Multiples of 4 that are part of x to the 5th, x to the 4th. And that would leave us with x. X to the 4th times x is our original x to the 5th. Y to the 8th, that is a multiple of 4, so we'll just have y to the 8th here. Break that up into separate radicals. We have the fourth root of 2 x y squared to the 4th. Let's check that. 2 to the 4th is our original 16. X to the 4th is our original x to the 4th. Y squared to the 4th is our original y to the 8th. And we still have the fourth root of 2x. When we take the fourth root of 2 to the 4th, that's simply 2. The fourth root of x to the 4th, however, that leaves us with x, even roots, so we need, and an odd power is what's left, so we need our absolute value, 2 times the absolute value of x. The y is being squared, so the fourth root of y squared to the 4th is simply y squared. And again, that leaves us with, over to the right, what's left under the radical, the fourth root of 2x.